Hey everybody, we're going to be talking about domain and range today. Now, we've been looking at graphs at middle school and in high school, and if you're like me, you've always thought of x's and y's. The x to be along this way and the y to be along that way. And then we learned to graph. Well, understand that that doesn't have to be x and that doesn't have to be y. You also probably been taught that the x was the independent variable and the y would be the dependent variable. Okay? So let's take just a simple equation. Y equals 2x plus 7. Now, what is the function of x? It would be the input, and to get the output y. So I would just plug in any kind of number to get that. So if I put a 1, if x is 1, that's 2 times 1 is 2 plus 7 is 9. So I would plug it in as a positive 1 with a positive 9. But what I want you to understand is not only is this the independent variable, the x, and the dependent variable is the y. Don't think about it as x and y at all. Think about it that this is my input value and this is my output. So I inputted a number here, 1, and it helped me get the output of the y value, or the whatever the function of x is y. Okay? So let's look at this in different terms. Like I said, it doesn't have to be x's and y's. It could be distance and time. Okay? So the time it takes me to get somewhere, and how far can I get in that time. So we could have something like distance equals 2 time plus 7. That's a t. So it doesn't have to be x's and y's. I want you to understand that. I want you to think about this is the input value and this is the output value. And over time that's going to make a lot more sense. Okay? Alright, so let's review a minute. We agreed that we're used to calling this the x-axis and this the y-axis, or the independent variable and the dependent variable. What we're going to need to know in questions that we're going to see on the test, that they're going to ask domain questions and range questions. So not only is this the domain, but it's also the input value. So think of this as domain or input value, and think of this as the range or the output value. Okay? So what you're going to see now is there are dots, and these lines should be drawn all the way out. But for simplistic purposes, I'm going to leave it like this. Okay? So let me just give you an example of one so you'll know what's going on. Okay? 1, this is positive going this way, and positive going this way. That would be negative and negative. So this dot right here is 1, 2, 3, 4. So 5. So a positive 5. And then we got to go down. 1, 2, 3, 3. A negative 3. So we drew that. It's not perfect, but you see. Okay? Alright, so when talking about range and domain, we need to get the range value. All the range values from lowest to highest. Now, the easiest way, and the way I was taught, is to take my hands and all these dots, think about squishing them in to the domain. Okay? And so what I mean by that is bring this down to the bring this down, and so forth. Bring everything down, and it doesn't matter if I'm drawing them straight. And then we bring this one up. Okay, so I have smushed all these dots onto on the domain, or the X, or the independent variable. Okay? And now we're going to take my pen and we're going to go this way. And I'm going to make a little beeping noise every time we come to a point. Remember, all these points are now along this independent variable or domain. So I go beep. Well, I stopped on -9. Beep. -8. Beep. -6. Beep, 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 and so on. Aggravating, is it? But I wanted to make that ridiculous sound to say that that's how I see it in my brain when I think about it. So let's plot this. Or let's look at all the range of functions that we can have. All right. So the domain is equal to, and then we never learn how to draw these little brackets, but let's just, that's horrible. Okay, I could redo that, but I guess I could right quick. And this ain't even right. So we go from lowest to highest. The range of domain values, we start with a -9, comma, -8, -6, comma, and on down. And then we end bracket. Okay? I would list all them points in here. That's what those little dots for. I just didn't name them all. Okay? So now let's do the range. Well, remember, for the domain, I smushed the hamburger this way. What do you think we're going to do for the range? Okay? And I'm going to go ahead and erase all these lines here because I don't want to get confused. What do you think we're going to do for the range? For the domain, we squished everything to the domain line. For the range, we're going to squish everything to the range line. So this is what we're going to do. We're going to bring everything this way. Smush it in this way. Now, okay? And we could have as many dots as possible, okay? So I smushed the range in, and so the range, we're looking at lowest to highest first. Well, there's no negative numbers in the range in this instant, okay? But let's just make one up right quick. Let's just put one here. So that would be 0, -3. So that would be -3 because we're only looking at the range. And then the next one is 0, 1, 2, 3, comma, 4, 5. There's 2 on the 5, but we only have to list 1. Then there's a 6, a 7, and a 9. And then we close the bracket. Okay? So for the value of the range, we look anywhere from a -3 all the way up to a 9. One other thing I want to go back and say. Now, I didn't put all the lines in here, okay? But think of that as a graph and all these points. this would be called a discrete graph because you don't have any line segments going from one line to the next. There's no lines in here, right? Alright, something else too. Let's say that you're getting things mixed up. You start watching the clock. Never watch the clock on a test, okay? But if you're feeling the crunch and you're like, okay, domain, range, which one's which? Oh, so this is what you do. Think of domain and range. Think of alphabetical order, okay? D comes before R, correct? Okay. X comes before Y. Alright? Now, as much as I want to erase everything that you've learned that this is the X line, I know you won't, okay? I want you to see it as the independent variable. I want you to see it as the input or the domain. But I know that you're also always going to see it as X. Alphabetical order, X comes before Y. D, domain, comes before R, range. What is the range? The Y, the range, the dependent variable, or the output. Alright, let's look at this for a minute now. Now, the reason I drew it like this is because we're used to seeing all the lines, but we only need the lines that the line segment is passing through. Okay, this is called a continuous graph. Okay, so now let's look at it. Remember we talked about compression. We want to look at all the numbers that the domain, sorry I wrote the wrong, the domain encompasses. So if we compressed it here, I want you to see that all these lines in here would be continuous. Okay? So we're pressing this line, compressing it. So it would start here. So here's your 0. Sorry, I didn't make that clear. That would be 0. 0, 0, right? 1, 2, 3, 4, 5. So that would be starting at -5. I've compressed it, and now I'm doing the beeps. Beep! And it would just continue beeping. Beep! Because see, this down to 0, all of this would be included in here, right? And if we compressed it, it would start beeping at -5, and it would go all the way up to 1, 2, 3, 4. Alright, so let's look at how we use notations here. There is a square bracket we got to look at, and then there's a rounded bracket. If the number -5 is included in the number, it gets a square. Now, if the domain goes up 2 but does not include 4, then you would get that kind of bracket. But since this does include 4, you would put the square brackets around it. So guys, I just want to review or go over this again. The rounded off brackets means, like if I put a rounded bracket here, it would mean that the domain goes up to 4 but doesn't include 4. Alright? But as far as this graph's concerned, if it does include 4, then we put the square brackets. Alright, so this was the domain. Now let's look at the range. Okay? Now we're going to compress it this way. Okay? we're compressing it this way. So here's a little beep indicator. Alright. Now I tell you what, something would be better if I take in green and I look at how it looks compressed that way. Okay? Remember, now our line gets compressed up that way. A while ago it was the domain, this line, I'm taking this line and I'm compressing it. Now we're going to compress it this way. So look at this. All this would get shaded in. Okay? And all this would get shaded in. Okay? So if this is the first line, this will be the last line because we smushed it in this way. Okay, so let's go with our line indicator. Beep, it would beep at -1, and it would be continuous beep up until 1, 2, 3, 4. So -1 beep all the way to a +4. So how would we list that? Well, now we're looking at the range equals. Now, that's a -1. We're going to include -1, right? So we're going to put that square bracket there. Okay? And we're going to put a comma and a continuous beep up to 4. And it does include 4. Alright, we're going to look at this and we are going to write out a interval notation and then a set notation. Alright, so we're going to look at this crazy looking graph here with these zigzag line segments, okay? And we're going to look at how to find the domain and how to find the range. Now we're going to look at set notation, and we're going to look at interval. We've already talked about the interval notation. So now, whether you like, if we're domain, if you like to start here and beep every time you see a point, beep, 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 or if you want to compress everything on the domain line, and you would bring all them lines down, up, okay? So, the first one here, this is 0. That's my 5, this is negative going this way. That would be -10. Now, does it include -10? Yes, it does. So we need a square bracket, right? Instead of one of those doohickeys, meaning that all points, but not included, -10. And then we go all the way over to a +10. That includes 10, okay? Now that's interval notation right there, okay? We need to look at how to do this same graph here in set notation. Alright, so set notation is a lot more mathematical than interval notation, okay? Well, I shouldn't say more of mathematical, but there is a way to do it, and you gotta do it right, okay? So what we first have to do is give our domain value, because we got to give it a variable. Let's call it x. So for this particular problem we're going to call this domain line x. Okay, so to write set notation, you first have to write, and let me make some room here. First, I have to get started with our first with our bracket, okay? And then we're going to be talking about the domain or the variable x. Now we're going to draw a line here. That just means such as, okay? So, the range as x values such as. Now we have a negative 10 on this side, 10 and 10. Okay, now we know the variable's x, so let's stick this x in there, okay? Now we have to use equality signs, inequality signs, okay? We know that negative 10 is greater than or equal to x, as it is also less than or equal to positive 10. Okay, now when we see this line underneath, it's just like having a bracket. If we didn't have that line underneath on both of these, it would be, we would use them curved brackets. Alright, to finish this out, we're looking at x, and then, sure you've seen this number for it, almost looks like an E. You seen that before? I don't want to call it an E, I shouldn't have called it that. In fact, this goes a little bit more up this way. Yeah, so that means all numbers that x can be, that including all values, and then we're looking at all real numbers. So we go up and we close our bracket. So I just want to review, okay? So this is set notation, looking at x such as negative 10 greater than or equal to the x, the domain, the variable, less than or equal to 10 for all numbers x that are, what kind of numbers are there? Well, they're, we've looked at integers, but these are all real numbers from negative 10 to 10. Alright, I made us a new graph, and we're now going to look at the set notation for the range. Now we're going to call it y, okay? Because we're going to need to call it something if we're going to do a set notation, okay? So now, when we're looking at the range, what we can do is we can use our little beep finder, and as we hit every point on the y-axis, we beep, 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 and that would start at, this is 0, so it'll be 1. A negative 2 is the lowest one, and then we go all the way up to 1, 2, 3, up to 3, okay? Now, if you don't like the little beeping sound, then we can just, when we're looking at the range, we want to compress it that way. That means all these lines out here will get pushed in to the middle. Okay? Everything's on this Y. And we're going to call this the Y. Okay? So, we're going to put our brackets out here. Okay? And if it seems like I'm pausing, to make sure that it's within the camera sight, because I taught the lesson a while ago and the camera wasn't even in there. So we're looking at y values as such. Remember, that line means y value, the range of y values as such. And then we just said negative 2, and then we up here 3. Okay? Now, y, negative 2 greater than or equal to y and less than equal to 3. And then we'll finish it up as the variable y, and all sets or all values that are real numbers, and then close the bracket. Alright, now we're going to do a lot more of those, so check that out in some other videos. Now one more thing I want to talk. Alright guys, let's talk about when is a function a function. Okay? Now, a function is when there is one input for every one output. Okay? Only one. So let's do the vertical line test and see if this touches in two places. And if we start here, we're going here, and then all of a sudden, look, this line touches in two spots. And it continues all the way. Here it does all of this. There are two outputs. You cannot have, well, I mean, it touches in multiple places, but it only has to touch in two places. If it touches in two places, it's not a function. Okay? So now let's look at this next example. And I apologize for my graphs. It's just that this is a new channel and I haven't purchased the technology yet. I first want to find out if I can even teach it. Okay, so let's just make a quick little graph here. Like I said, forgive my lines. Okay, and we know we've got some lines going like this, and got some lines going like this. Okay. Now, let's say that I have 2 points. Let's just make some points here. Some line segments here. Okay. Okay. Okay, so let's do the vertical line test again and see if this is a function. Remember, if it's a function, only one input for every one output. So here we go. Okay, that touches one time. That touches twice. So that is not a function because it touches two places. Now let's keep going. And everything else is fine. So only right here is this not a function right here, because the vertical line test, the line comes and it hits 2 points. And you can't have that. It means it's not a function. Okay? What if we did, and I'll do this in green, what if I did this? Is that a function? Well, let's do the vertical line test and see if it touches at least 2 places. Here we go. No, it doesn't. So that is a function. Alright guys, so we talked about a lot today, right? And so let's just quickly recap. Alright guys, today's lesson was a little bit long, but we talked about the domain and the range. And just quickly, a quick review. I want you to get away from looking that is an X and that is a Y. I want you to look at what you used to call X. X is the domain, as the independent variable, and as the input. We're going to input something into the equation to get the output. We're going to quit looking at this as the Y value. We're going to look at this as the not only the dependable variable, but the range. Okay? And then we talked about what is a function and what is not a function, and we plotted some, and we looked at interval notations and set notations. And so I hope all that helped you, and keep learning that math. Let's pass this test, and let's even go further and maybe do some other fun things or interesting things with a career in math. Who needs all that? We just want to pass the test.